Welcome back, students. In this lecture, we'll see how to find out slope of a curve. We initially, in the previous lecture, we studied that how important the slope of a curve is, because that gives us enormous amount of information about the variation of one parameter with respect to the other. Let's recap something which we did on that day. Let's say this is position time graph of a body, and I say that the position time graph is like this. What information can you draw about the velocity of the body by looking at the curve? At what times, whether the velocity was increasing, whether it was decreasing. Now the curve is going up. What does that mean? Does that mean that the velocity is increasing or decreasing? Did there were some points when velocity was maximum? Was there some point when velocity was zero or was minimum? Can we see these things? Did velocity become negative during this time? There's so many things which I can draw information about from this curve. Look at it. If I understand that slope of a curve means what? Slope means if I am drawing a graph between y and x, or for that matter, let's say x and t as it has been shown in this graph. It basically tells me, the slope will tell me as the time is passing by, as time is changing, how rapidly x is changing. Now, if I am moving slowly, then with the passage of time, x will change slowly, and if I am moving fast, with the passage of time, my position, that is x, is also going to change fast. That means the slope of the curve of position time graph represents velocity. How fast I am moving is represented not by position time graph but by slope of position time graph. And slope is what? I told you that day that slope is basically, by looking at the curve, you will see how steep the curve is going up or going down. Is it flat? If it's flat, the slope is zero. If it's going up really sharply, the slope is high. So at these points, what do I see? Imagine a person climbing on this curve. Think of it as if it's a mountain and someone is climbing up on this mountain, and look at it. If that person wish to climb up over here, the curve is really steep. It is really difficult for that man to go up. The slope is high, and slope of position time graph represents velocity. This means that at this point, the velocity of the body, which is whose graph it is, that velocity is high. As he goes up there, the curve has become flat. That means at this point, the velocity of the body was zero. So, I wanted to tell you that don't just get confused. The curve is going up, that means velocity is increasing. No. It's a position time graph. The curve is going up, that means the body is going farther away from origin, but at the same time its velocity is increasing, and finally it became zero, and suddenly then the slope becomes negative. That means the body has started in the opposite direction. Its velocity is going down now. And at this point, the curve is again flat. The velocity is again zero, and it again increases and becomes zero and zero and zero. Now, just by looking at how steep the curve is going up or down, you have gathered information about its velocity. Although you were given only a position time graph, but you can draw inferences about the velocity of the body. At the same time, can you tell me at what time the velocity became maximum and at what time the velocity became minimum? These were the times. Is there any mathematical way of finding out where a parameter attains its maximum or minimum without looking at the curve? These are the things which are of extreme importance in physics, and we regularly use them. And in today's lecture, we'll try to learn about these things. The mathematical operation which obviously the mathematicians have learned for us physicists, is called differentiation. Differentiation is that mathematical operation which tells us about the slope of a curve. We don't have to draw the curve, we can mathematically obtain it. And there are certain formulas. Now the derivation of those formulas also exists, but that exists in the books of mathematics. We don't need to derive those formulas, we'll borrow those formulas from mathematicians. I'll give you a list of few formulas and then we'll, by example, see how to use those formulas to find out slope of a curve and how important that is. It's interesting that we'll not have to derive these formulas, only the mathematics people. हमें पेड़ नहीं उगाने हैं, सिर्फ आम खाने हैं. सिर्फ आम खाने के लिए क्या करना है? Let's see. The formulas have been developed by mathematicians. We are simply going to use them. So there are a number of formulas. I'll tell you a few of them which are regularly used by physicists, or you may say that you require in your +1 or +2 physics. That's these formulas. I'll tell you. The first formula is, if you have got y in the form of an equation where you have got x raised to the power n can be anything, positive, negative, fraction, 0, anything. If you have got some equation of this sort, y is equal to x raised to the power n, and you wish to find out the slope of the curve. Let's say something like this. This is the curve. So what do? We say, okay, take small change in x, we call that dx. Dx doesn't mean something d multiplied by x. Dx in physics means small change in x. And see correspondingly how much the value of y has changed. That change in the value of y is called dy. The slope or the steepness of this curve is given by the tangent of the angle which this curve is making over here. Slope is equal to tangent theta, which is obviously equal to perpendicular over base, is equal to dy by dx. So slope, and that has become the symbol of differentiation now. For example, for multiplication you use this, for addition you use this. Simply for differentiation you will use something like this, ddx of y. You may read it like dy by dx, you may read it like ddx of y. This simply means that how a change in y occurred as I changed x to small value. Now, if the graph is between y and x, you may write it down as dy by dx. Had the graph between x and t, it could have been written as dx by dt. Whatever is along y-axis is written in the numerator, and whatever is along the x-axis is written in the denominator. It's not as simple, but for we are assuming mutually independent parameters. No, let's not go into detail. Forget it. It has become a symbol for differentiation. So if y is equal to x raised to the power n, the differentiation now, keep it in memory, commit it to memory, that dy by dx, whatever is there, write it down there, and decrease the power of x by 1. This is the first formula. If y is of the form of x raised to the power n, then dy by dx is equal to n x raised to the power n minus 1. dy by dx gives us the slope of the curve. That slope of the curve is nothing but the tangent of the angle which that curve makes with the positive direction of x-axis, and this gives us how rapidly y changes with respect to changing x. Now I'll leave this discussion of the physical senses. We'll simply do the mathematical part of it. How to differentiate a function. If y is equal to x raised to the power n, dy by dx is equal to n x raised to the power n minus 1. For example, if y is equal to, I say y is equal to x raised to the power 6, what would be its differentiation? You'll say dy by dx is equal to 6x raised to the power 5. It's as simple as that. Let's do a few more examples of it. Let's say y is equal to under root x. This is not of the form of this formula. Y is equal to x raised to power n. This is not of the same kind, but it can be changed because we know under root is nothing but raised to the power 1 by 2. Now it is y is equal to x raised to the power n. In this case, n is equal to 1 by 2. So what is dy by dx? It is equal to 1 by 2 x raised to power 1 by 2 minus 1, which turns out to be minus 1 by 2. You can write it down something like this, 1 by 2 under root x, because negative power you take it to the denominator and the power becomes positive, and power 1 by 2 can be written as under root. If you want to write it down like that way, it's okay. If you don't want to, even then it's okay. d1 dy by dx. This is the differentiation of x raised to power 1 by 2. But let's say y is equal to 1 by x. Can you differentiate it? You can pause the video and try it. Y is equal to 1 by x. I hope you have tried it. You change its shape in this form. How would you do that? It is x raised to the power 1. X raised to the power 1 is in the denominator. So y is equal to x raised to the power minus 1 if you write down it in numerator. Now, dy by dx, apply the same formula. Whatever is the power, you write it down over there and decrease the power by 1. So it was already minus 1. So minus 1 becomes minus 2. So what is dy by dx? It is equal to minus 1 by x square. So this is a simple first formula, that if you have got y as function of x in the form x raised to the power n, then the slope of the curve can be obtained by n x raised to the power n minus 1. This is the first formula. Let's move on to the second formula. What if y is a constant? If y is a constant, dy by dx is 0. The differentiation of any constant is always 0, no matter how big or how small that constant is. Let's say y is equal to 3, dy by dx will be equal to 0. If y is equal to 3000, even then dy by dx would always be 0. If it is 1 by 2, it is 5 by 2, it is under root 2, whatever. It is positive or a negative number. If it's a number, it's a constant. dy by dx, the slope is 0. Can you draw physical inferences from this formula? If y is a constant, that means even if x keeps on changing, the value of y is not changing. So what is the angle which this curve is making with the positive direction of x-axis? It is making 0 degree. So what is the slope? Tangent theta, that will turn out to be 0. Therefore, differentiation of any constant is always 0. This is the second formula. Let's move on to the third formula. What if y is equal to some constant c multiplied by x raised to the power n? We already know what was the differentiation for x raised to the power n. I hope you remember, that was n into x raised to the power n minus 1. But what if there is some constant c before that x raised to the power n being multiplied by it? No problem. dy by dx would be c into n into x raised to the power n minus 1. So simply this n get multiplied with this constant c. For example, if y is equal to 3x square, what would be dy by dx? This 2 and 3 get multiplied as 6, and x raised to the power, whatever it was, get decreased by 1 unit. It is 2, so it get decreased by 1 unit, that is, it becomes 1. If it is 2, it becomes 1. If it is 3, it becomes 2. If it is minus 1, it becomes minus 2. It's as simple as that. Can you do this? Y is equal to 9x cube. Pause the video, try it. It is 27x squared. I hope you understand it. Now, let's move on to the next formula. What if y is equal to some c x raised to power n plus some c dash x raised to power n dash or something like that. That means two terms are being added up, or even for that matter, let's say being subtracted. Example, let's say 3x squared minus 4x plus 7, like that. No problems. We simply differentiate them individually. And if there is negative sign, write down negative. If it is positive sign, write down positive. For example, how would you differentiate it? Differentiate this. 2 into 3, it is 6x raised to the power, it was 2, now it will become 1 in a decrease, it will become 1, x raised to the power 1. It is minus, I write down minus, it is x raised to the power 1. So 1 into 4 into x raised to the power 0. Anything raised to the power 0 is called 1. And it is a constant, differentiation of constant is 0. So what is dy by dx? It is equal to 6x minus 4, that's the answer. This is how, if the terms are being added up, they get differentiated. What if two terms, let's say, first term I call it u, the other term I call as v. So in general, if there are two terms like that, dy by dx can be written as du by dx. If there was plus, you write down plus. If there is negative, you write down negative. And dv by dx, that's the general formula. And if there are more terms like that, you can add on those terms over there. But what if these two terms are being multiplied? How do you do that? Let's say there are two terms and they are getting multiplied, u into v. So what do? The formula which mathematics people have learned for us says, write down u without doing anything to it. Multiplied by differentiation of v. Then put a plus sign from your own side. Now the second factor, v, is written without doing anything to it, and differentiate the first factor. This is the formula. So u into v, the differentiation will be u into differentiation of v plus v into differentiation of u. I give you an example. Let's say y is equal to 6x squared plus 7x plus 3 multiplied by 4x cubed plus 9x plus 2. How do you do the differentiation? Now there are two terms, one bracket and the other bracket, and the two brackets are getting multiplied. This is a function of x. That means it's an equation in x. This is also an equation in x. So write down the first equation as such. And differentiate the second equation, the second bracket. How would you differentiate it? 3 into 4, it is 12. It was 3, it becomes 2 over here, plus x raised to the power 1. So 1 and 9 get multiplied, 9x raised to the power 0. This is a constant, its differentiation becomes 0. This much part has been solved. Plus, earlier I wrote down the first bracket as such and differentiated the second bracket. Now what will I do? I'll write down the second bracket as such and differentiate the first. The second bracket as such, 4x cubed plus 9x plus 2, and differentiate the first bracket now. The first bracket, 6 into 2, it is 12 x raised to the power 1. It was 2 over here, it becomes 1 over here, plus 7 x raised to the power 0. It becomes 7 x raised to the power 0, plus 3 was a constant, its differentiation is 0. You can algebraically solve it out, or you can leave it up to this point only. This is absolutely correct. So this is the differentiate. This is the formula for differentiation when two terms, two functions of x are being multiplied. What will you do if two functions are being divided? The next formula. U over v, dy by dx is equal to, the formula says whatever is in the denominator without any change, write down square of it in the denominator itself. Then write down the denominator without any change and differentiate the numerator minus the numerator and differentiation of denominator. I take an example. Y is equal to 3x square plus 4x and 5x square plus 3x. How to differentiate it? dy by dx would be equal to whatever is there, write down x square in the denominator. Write down the same denominator again over there and differentiate the numerator. 5x square plus 3x. This 2 and 5 get multiplied. 10x raised to the power 1 plus 3x raised to the power 0 minus what do we have? Now I will write down the numerator without any change and differentiate the denominator. Denominator is 3 into 2, 6 times x raised to the power 1 plus 4 times x raised to the power 0. This is the answer. This is how we differentiate two functions when they are being divided with each other. There are a few more formulas which we need to know. Like for sin x, differentiation is cos x. For cos x, differentiation is minus sin x. For tangent x, differentiation is secant square x. For cotangent x, differentiation is minus cosecant square x. For secant x, differentiation is secant x tangent x, and for y is equal to cosecant x, dy by dx is minus cosecant x cotangent x. Just for the sake of developing the method to keep them in mind, there are 6 T ratios: sine, tan and secant, and cosine, cotangent and cosecant. These T ratios have got co as their prefix. Cosine, cosecant, cotangent. Whenever there is co prefix, you will get a negative sign in its differentiation. And whenever there is no co prefix, like sine, secant and tangent, you will get the answer as positive. This is just a way of remembering the formulas. 2 more formulas, really important. If y is equal to log of x, dy by dx is equal to 1 over x, and if y is equal to e raised to power x, no change, dy by dx will still be e raised to power x. So these are basic formulas. Just by noting down these formulas, you won't be able to do any differentiation, but this is the first step. You should practice a lot. Take out any +1 book and solve as many questions as you can. If you cannot solve some question, write it down in the comment box. I'll definitely solve it for you in the next video. But there is one more important part to it which I wanted to discuss. How to know when a curve attains its maximum value or a minimum value, when a function attains a maximum or when it attains a minimum. There is a concrete way of finding it out. Without drawing the curve, but I am drawing the curve just to explain the concept. Note down that whenever a curve attains its maxima, the curve will become flat at the top. Similarly, whenever a curve attains its minima, it will again become flat at the bottom. That means that whenever a curve or a function attains its maxima or minima, its slope is 0 at that time. at that point. That means that slope is obtained by differentiation. So if you are asked to find out when the velocity becomes maximum, when this thing becomes minimum, you have to simply differentiate it and equate it to 0, because whenever a function attains a maxima or a minima, its differentiation would be 0. And whether it is a maxima or a minima is obtained by the second derivative. I'll tell you how. Let's say the question says that the position of a body is given as it is 9t cubed minus 7t square plus 2t plus 5. You put in the value of t and it will give you the value of the position. At what time the body was farthest or closest to origin? At what time the body was at farthest or closest to origin? This is the question. How would you do it? By looking at this. At what time? Will you keep on putting the time from 1 second, 2 seconds, 3 seconds up to infinite number of seconds to see? No. There is a specific method of doing that. What would you do? This is a xt graph. This is a xt function. So differentiate it and put it equal to 0. Because this is the slope of the curve. And whenever the body was at its farthest position, that means x was attaining its maximum value, and whenever the body was closest to origin, that means the body was the curve was obtaining its minimum. So at both the points its differentiation should be 0. So differentiate it and put it equal to 0. How would you do that? This is equal to, it will be 27t square minus 14t plus 2. This is a quadratic in t, and t can be solved. How would you solve it? How would you solve it? It is minus b plus minus under the root b square minus 4ac divided by 2a. You will get two values of time. Obtain those values. These were the two times when the position of the body was either maximum or minimum. Now, the second part would be, you want to know whether it was maximum or minimum. What would you do? Differentiate it further. That is called double derivative. We write it down as d square x by dt square. d square x by dt square. Differentiate it further. It becomes 27 into 2. It is 54t minus 14. Whatever t values you had obtained, put in those t values in this equation. If the double derivative turns out to be positive for a particular value of t, that time corresponds to a minimum in the curve. In this case, minima in the position means being closest. And if double derivative turns out to be negative, that by putting in these values t1 and t2, that time will correspond to a maximum. At that time, the body is at farthest point. So the mathematics plays an important role, because we don't have to draw the curves, we don't have to put in the values infinite number of times. A very concrete mathematical method can tell you how and when a function becomes maximum or minimum. This is something which we repeatedly use in physics and is of extreme importance. I hope you carefully do this thing, solve this quadratic equation and put in these values and write in the comment box whether T1 was minima or maxima, T2 was minima or maxima, and how much farthest that body went away. So you can put in these values of T1 in this equation to find out x, T1 and T2. You can put it to find out x1 and x2 to verify your results.